array of integer nums, and we are also giving an integer target. So we're going to return the number of non-empty subsequences of nums such that the sum of the minimum and maximum element on it is less than or equal to target. So since the answer can be really large, so we're going to return a modular of 10 to the power of 9 plus 7. Yeah, so let's just prepare the mod first. Yeah. So for this problem, as the number can be really large, and also we are giving this kind of integer of nums and with a target, we want to find some numbers. So for example, 3 and 5, this subsequence 3 plus 5, it is less than 9, and also for 3 it is less than 9, or 3 5 6, or 3 6. Yeah, so in total it's gonna have four subsequences that satisfy the condition, so we're gonna return a 4. Yeah, so according to this first example, we might think, so maybe we're gonna sort the nums array. Maybe it is helpful. Yeah, because definitely the length of the array is 10 to the power 5. If we sort it, definitely it is okay, because it's going to be n log n time complexity. Yeah, so what if we can sort the nums, so it's going to become 3 5 6 and 7. Then we're going to use two pointers to check if it is possible. Yeah, and we're going to use two pointers to find how many different cases. Yeah, so first of all, from the left side we're going to have 3, and from the right side we're going to have 7. 3 plus 7, it is 10. 10 is more than 9. Yeah, so this means that definitely it is not possible, so we're going to shift the right pointer to the left. Yeah, so instead of we shift the left pointer to the right, because that's going to be bigger. Currently we want it to be smaller, less than or equal to the target, so definitely we're going to shift the I pointer. So currently we're going to still have 3 5 6 and 7, so the R pointer going to be at the 6, and the left pointer going to be this is 3. Yeah, now we are okay, because 3 plus 6, it is 9. 9 going to be more than or equal to the target. Yeah, so definitely it means 3 and 6 must be okay. Yeah, but how many different cases? Because currently in this condition, according to the two pointers algorithm, we always want to shift the left pointer. But how can we shift the left pointer? We need to count how many different cases. Yeah, actually it's going to be like this is a 3, so it's going to combine with different cases. It can be empty, so this means we only have a 3, or it can be a 5, or it can be a 6. Yeah, so this means a 3 5 and 3 6, or it may have a 5 and 6. Yeah, so 3 can combine with different cases. How many different cases? It is 2 to the power of 2, because there are two numbers. Yeah, because definitely we want to have a smallest number, 3, and then we're gonna choose any of the other numbers inside of the set of 5 and 6. Yeah, we can also include 5 and 6, because the maximum number is gonna be 6. This is 6, this is 5, and this is the maximum number gonna be nothing. It's gonna be this is 3. Yeah. So similarly, if we have 3 4 5 6, and this is the left pointer, 6 is the right pointer, so how many different cases? Yeah, we just need to check how many subsets of the set 4 5 6, and they're going to be 8. Yeah, because it's going to be 2 to the power of 3. So yeah, in this case it's going to be 8 different cases, and in this case 3 5 6, and it's going to have 4 different cases. Yeah, so as you can see, in this way we can solve it easily by using the greedy idea, and then we're going to use the two pointers to solve the problem. Yeah. Now let's first sort the nums array, and prepare a left and right pointer, and prepare the final result, and we're going to use a while loop to check. Yeah, so while left pointer less than the right pointer, so I'm gonna have an answer. It's gonna be the left side plus the right side. Yeah, so if the answer is more than the target, I'm gonna update the right pointer, else I'm gonna update the left pointer, but before that I'm gonna update the final result. It's gonna be 2 to the power of r minus l, and I'm gonna update the left pointer, and I'm gonna return the result. Yeah. So this is R minus L because, for example, we have 3, 5, 6. Yeah. So this is the left pointer L. This is the right pointer. And how many different cases? R minus L is going to be 2. 2 to the power of 2, it's going to be 4. It's going to be 4 different cases. Definitely, it means we're going to have a combination of 3 with the subset of 5 and 6. So for 5 and 6, the subset, we're going to have 4 different subsets. And then we're going to have 4 different cases. Yeah. And after that, we are okay. We are safe to update the left pointer to the next position. Because for the 3, we've already used all different cases, and we are safe to shift to the left pointer because the array has already been unsorted. So after sorting, definitely we're going to use 2 pointers to solve it. Yeah. So the final result gonna modular a mod because yeah, this is what we are getting because the final result can be really large, so we're gonna modular a mod. Yeah. Now let me just run it. It didn't work. Let me check why it worked. Yeah, this is not expected. Yeah, this is the left pointer, the right pointer. Let me think about it. So the left pointer should be less than the right pointer, but we still have a case. I mean, the left pointer gonna equal to the right pointer. Yeah. So for example, in between there are gonna be some numbers. So our target is 9, but in the middle maybe there are some numbers 4. So this is L and this is R. Yeah. Oh, it cannot be equal. I mean, the left pointer should not equal to the right pointer. Otherwise, the left pointer can equal to the right pointer. Let me think about it. Yeah, if the left pointer equal to the right pointer, so this means yeah, this means from here 2 to the power of 0 it's going to be a 1, so the final result is going to plus a 1. Yeah. So this is just a special case, so sometimes we need to check the 2 pointers it can be equal or not. So in this case it can be equal because, so for example, in the middle there is a number 4, and this is the L pointer, this is the right pointer, it also pointed to this number 4. Yeah. So this means for this number 4, it can also be valid. Let me actually yeah, let me use this example. So yeah, if the target is 12, let's just use the third example to explain this case. So we're gonna have 2, 3, 3, 4, 6, 7. Yeah. So first of all, this is the left pointer, and this is the right pointer, and 2 plus 7 gonna be less than the target. So how many different cases? We're gonna have 2 to the power of 5. Yeah, which is equal to 32. Now we are safe to update the left pointer. So 3 plus 7, it is also okay. So it's gonna be 2 to the power of 4. So it's gonna be have 16 different kind of cases, and then we're gonna still update it. It's gonna be 3 to 7. 3 plus 7 is less than 12. It is okay. So we're gonna plus 2 to the power of 3. So it's gonna be 8. Yeah, and we're gonna continue to this number 4. So for this 4, it is gonna be 2 to the power of 2. It's gonna be 4. Yeah. Next, we're gonna continue to this 6 and 7. This is the L pointer. This is the R pointer. Here the strange thing happens. But before that, let's just sum up all those values. 32, 16, 48, 56, and plus 4, it's gonna be 60. Yeah. Now what left behind is only this 6 and 7. So for this 6 and 7, this is the L pointer, this is the R pointer. Because 6 plus 7 gonna be more than the target, we're gonna shift to the R pointer. So the R pointer and L pointer gonna be at the same position. It is this number 6. Yeah, as we know, this 6 gonna be a valid answer. Yeah, so according to this equal sign, we're gonna combine this 6 inside. Although the answer is 12, but this 12 is less than or equal to the 12 targets, so we're gonna still plus the final answer. So it's gonna be 2 to the power of 0. So the result gonna plus 1, which is gonna be 61. Yeah. So we actually combine this this one inside the code of L equal to R. It seems it's a little bit difficult to understand here. Yeah. So this is actually some calculations. So for the next numbers, it is a 6, 7, or maybe it is a 5 and 8. Definitely this 5 should be possible if the target is 12. Yeah, definitely one of the number is smaller, another number is bigger. Yeah, so even 2 times this number should be less than. So even for 6 plus 6 should be less than here 6 plus 7. So what about this number is 7? Yeah, let me just submit it. Maybe this is not okay. Yeah, this one works. Yeah, but what if we have like 2, 3, 3, 4, 6, 7? Yep. But what if we have 7 and 7? So this is L and this is R, because they are more than the target, so R gonna be shifted to L, and if L less than or equal, so we're gonna have an answer. So the answer gonna be 14. Yeah, let me just print it out some testing cases to check. So I'm gonna add another testing case. So this is gonna be 7. Yeah, and I'm gonna just test this case, and I will to print out the result. So it's gonna be this one. It's gonna be 60, and finally it's gonna be 60, and but for case 3 it's gonna be 61. Yeah, because we changed this 6 to 7. Yeah, so for this case, because it is a 6 plus 6, it is less than or equal to 12, it is okay. Yeah, so that is why in total it's going to be 61. And for this case, it is 7. Yeah, so yeah, so what is the difference between this 6, 7 and 7 and 7? So for this 6 and 7, we can choose 6, or we can choose 7. Yeah, but before it, for example, it is yeah, I don't understand about here, so maybe I'm gonna talk about it next time.